Hi everyone, I'm just going to be building model 4-1 for you again, this time to reflect the latest version of this model as of spring 2021. So we are told, well, first off, we can see that the whole flow of the parts is given here. We have parts that are incoming, there's a transfer, they're prepped, they're transferred, it goes to a sealer machine, and then they're either shipped or reworked. Then after the rework, they're either salvaged or scrapped. So we have here two types of parts that arrive in the assembly area, part A and part B. Let's go part A and part B. I'm going to name this part A arrives. The entity is part A. And the inter-arrival times are exponentially distributed with a mean of 5 minutes. Okay. My cats are fighting, sorry. And then we have part B, which also arrives in inter-arrival times are again exponentially distributed, this time with a mean of 30 minutes. And we're told that it arrives in batches of 4. So we have 4 entities per arrival. Upon arrival, part A is transferred to the part A prep area, taking 2 minutes. So we can use a delay module to represent this transfer. I'm going to click on this first and then drag it so that the connection is automatically connected, because I like to do that. So this is transfer to part A. This delay time is 2 minutes. Okay. And then part A prep is a workstation with a single operator. So this right here tells me that this is going to be a process with a resource. So let's go in, bring in this process. So this is now the part A prep area. This has a process time distributed according to a triangular distribution. 1, 4, and 8. And we know that it has this single operator. So we want to add a resource. So we're going to add a prep operator. And we only need one of this guy to run this process. We're going to click OK. So that takes care of the first 5 bullets. Upon arrival, the batches of part B are transferred to the part B prep area with travel times distributed according to an exponential distribution with a mean of 2 minutes. So let's bring in another delay. This time, this is transfer to part B. And this delay is an exponential distribution with a mean of 2 minutes. So I know this arena expression. I can type it out directly. But if I didn't know, or I wanted to make sure I wasn't making a mistake, I can right click and go to the expression builder, click on random distributions, exponential, there's a mean of 5, and we can insert this expression. So then part B Prep area is a workstation with one operator and has a process time distributed according to a triangular distribution with a mean value of 3, a mode of 5, and a max value of 10. So let's bring in another process module. B prep area. Again, this is a seize delay release. And this time, it's not going to be the A prep operator, it's going to be the B prep operator. It is still triangular, but it is 3, 5, and 10. Okay, so we have that. Once parts A and B have been prepped, they are transferred to the sealer area. Part A has travel times taking 1 to 3 minutes, uniformly distributed. Part B has travel times distributed according to a triangular distribution with a min value of 1, a mode of 1.5, and a max value of 3.5. So let's put in these two delays. We've got the B transfer to sealer, and we have part A is being transferred to the sealer. So let's name these A to sealer. And this is uniform from 1 to 3. Again, we can right click and go to the expression builder, random distributions, uniform between 1 and 3, or you can just type in directly unif 13 minutes. Okay. And then B to sealer is a triangular distribution with a min of 1, a mode of 1.5, and a max of 3.5. So again, I could type it in directly, but we'll go to the expression builder, select triangular distribution, and this is 1, 1.5, 3.5. Okay, and this is in minutes. At the sealer, a machine that requires 2 operators to run, the electronic units are assembled, sealed, and tested by the sealer machine. The process time depends on the part type. So now we have 2 different process times. So it's the same process module. It's a single line. It's the same set of resources. The process is defined the same way. So we can use a single process module. And well, let's call this sealer. We have 2 types of resources. We have the machine that we need 1 of, and we have the sealer operator, which we need 2 of. And now the question becomes, what do we do for the delay? We're going to say that this is an expression in minutes, but we are going to leave this as blank. We're going to put in a placeholder, a variable name. So we'll call this sealer time. Okay. Then we are told that 91% of the parts pass inspection and leave the assembly and test area for shipping, a transfer that takes 2 minutes. So first we want to decide if it's going to pass inspection. And we say pass inspection, question mark. And we say that 91% of parts do pass inspection. If they pass inspection, they're going to be transferred. shipping, 2 minutes. Okay. Let me call this. And they are shipped. So we're going to put in a discard, a dispose. Okay, so now what happens to the remainder of the parts, the remaining 9%? So the remaining 9% of parts are sent to the rework area where there are 2 rework technicians. The transfer time to the workstation takes 30 seconds, and the rework time follows an exponential distribution regardless of part type with a mean of 45. So let's bring in another delay for this transfer. This is going to be transfer to rework. This takes 30 seconds. I could have written 0.5 minutes, but it takes 30 seconds. And then we get to the rework area. We have resources that we need to use. So we're going to do seize delay release. And the resource is going to be our rework tech. We have 2 rework techs, but we only need one of them to run this process. So we're going to be seizing 1 unit here. And this follows an exponential distribution. The mean of 45 minutes. Okay. Now, before I forget, let me go to my resource section and make sure that I have 2 sealer operators and I have 2 rework techs for now. Then we're told that 80% of the rework parts are salvaged and leave the assembly and test area for shipping, and the remaining parts are discarded as scrap. So we're going to do another split. Move some of these things. We're going to say, was the rework good? 80% of them pass inspection the second time and go to shipping. So we can connect this. I think in a previous iteration, I created a separate output. That is also correct, but in this instance, I wanted to just show you something a little bit different. So we have our shipping, and then the remaining 20% of parts are scrapped. Now, before we move on, let's see, need more room. No. Now, this model looks okay, but if you recall in the sealer module, We did not fill out what the sealer time is. We just created an expression calling it sealer time. So what I'm going to do is I'm going to move these guys over. And right when my part arrives, I'm going to create an assign. I'm going to put an assign module. I do one for each. Now, this assign module can be placed anywhere before you arrive to the sealer. So I'm just putting it right in the front because why not? The minute this part arrives, we can already determine what its random process times are going to be. So now we look at this type of assignment and we have several possibilities. And so you might think that since we are trying to label something sealer time and give it a distribution, we would want to use a variable. We're used to using that word variable to represent things that change. But in Arena, variables are used for the system as a whole and get overwritten every time they're defined. Attributes are entity-specific variables. So every time a part A will come through, each part A will have a variable that will be called sealer time. And that variable will have a value of something with this distribution. And then as these part A's travel through our system, this attribute sealer time is always attached to it, a little packet of information that follows it around. So we're going to do the same thing for part B. We're going to add an attribute and we're going to call it, should be in the list, yes, it was previously defined, so it's here, sealer time. And this is going to be a Weibull distribution 2.5, 5.3, okay. So now every part that arrives, it will pass through one of these two assign modules, and it will have an entity-specific variable that is an attribute. It'll have an attribute called sealer time, and then that sealer time will be irrelevant until we get to this sealer process. And at this point, when Arena sees this expression sealer time, it will go back and it'll say, where was this previously defined? Oh, it was previously defined here. I'm going to apply it here. So this is now everything up until this bullet point. The simulation must run for 4 consecutive 8-hour shifts. So I'm going to go to Run Setup, and I could do this, I could type out 32 hours, and that would be perfectly valid. Or I can say that this is going to be 4 days with each day lasting 8 hours, and that's also valid. So depending on how you want to view your statistics, you can type this in any way you want. I'm just going to make it easy and say it is 32 consecutive hours. We'll keep 8 hours per day, 8 hours per shift. And I'm going to want to look at all my statistics in minutes. Let me go model 4.1. So that's here. And then the performance measures of interest are resource utilization, and that will be in the resources default. Well, actually, let's go ahead and press play. Let's see what happens. Okay, so our performance metrics of interest are resource utilization, and we can see that with our resources, we have this utilization is given to us. We want to know the average number in queue. So we can look and see the average number in queue. We want to know the time in queue. So that's here. And then we want to know the timing system of first time through parts, timing system of salvaged parts, timing system of scrapped parts. So you might want to go and look at this, and you can go see that the times are broken down by entity type, part A and part B, but we don't have anything that is going to give us this timing system. So we're going to have to create our own statistics. So let me stop this and go back to the model. And the way we want to measure time and system is we can take a timestamp at the beginning and check the timestamp at the end, and that will give us our time and system for each of the parts. So I'm going to do a timestamp at the beginning, and I'm going to add an attribute named arrival time. And I'm going to do a date and time functions. I want to know the current simulation time, T now. Okay. I'm going to do the same thing for part B. So every time part B arrives, I want to capture that timestamp, go to attribute, arrival time, and I already know the expression now, so I'll write out T now. Okay. And then right before we leave, we want to keep track of these times in system. So we can use this module, the record module. So we're going to record first time through stats. And what we want to do is we want to look at a time interval from the arrival time to a data set. We could give this data set a name, and we'll call this first time through time in system. We can also do a count. I'm just going to count the number of parts that are first time through. Okay, and then we want to do the same thing for the salvaged parts and the scrapped parts. So I'm just going to copy this and paste it here, paste it here. But be warned that even though this looks like it's connected, it's actually not, because I just put it on top. So I'm going to have to delete these connections and reform them. I'm going to double click here so that this connect tool stays on. So I can do multiple connections all at once. Okay. This is looking very messy. Okay. And then I want to, of course, change these. So this is, we're not looking at first time through. These are the salvaged stats. And we want to name this salvaged payment system, and we're going to count salvaged. Okay. And then we're going to update this. So this is record stats. Okay. So now that I have created these 3 custom statistics, I'm going to play this again. Yes, let's see the results. And now we have a 4th category of user specified. We can come in and look and see that the average time in system first time through was 61 minutes. For salvaged parts, it's 101 minutes. For scrap parts, it's 159 minutes. And then we can look at the number of parts. We can calculate a percentage if we wanted. But realize that this is based off of a single replication. Even though we had all of these parts going through, they're all correlated. So that is to say that one part's wait time is going to be correlated with the part before its wait time and the part after its wait time, right? So we can only count this as a single replication, and that is bad statistics to say that the average is 61. This is just a single value, a single point. So I guess that's it. Yes, so we'll just close this out, and I'll see you for model 4-2.